Hello, I'm John Joshua Bologna and I'm here once again with a Python experiment for you. This experiment will be experimenting on Boolean values and conditional execution. In our first scenario, we will be tasked to have the input to be measured against 100. If it is greater than 100, it should return true. If it is less than 100, it should be false. If it is equal to 100, it should be also returning true. So here is the code. And let's see in a sandbox. Now take note in the sandbox that the print function does not have to have a parenthesis here. So it is just weird. But putting aside that, so we have input as 55, it should be returning false. And our second input should be 99, 100, then 101. Let's just run it. 99 should be false. 100 should be true because it is equal to 100. 101 should be equal to should be returning true also. And then our two last inputs are -5 and positive 123. So we have -5 should be returning false, and positive 123 should be returning true. So the code works. For our part 2, we have the comparison operator and conditional execution, wherein we are tasked to input Spotifylum so that we could output this statement. If the Spotifylum, however, has inputted a small s, not a big S, it would return this statement. And if the input is not Spotifylum at all, it should return the input Spotifylum, not the input. So here is our code. Let's copy it. Take note that the input is a string. So, and that there are parentheses here, but it does not need that. So it would probably print the parentheses, but no matter. So if we print the Spotifylum with a small s, it should return, no, I want a big Spotifylum. So if we input it here, yeah, so it says, no, I want a big Spotifylum. If it is anything but Spotifylum, it should return as Spotifylum, not the input. So Spotifylum, not the input. And you notice the commas because of the quirk of the Python sandbox here that should not be having parentheses at all. Let's try that again with no parentheses, and it returns to normal. But in reality, the print function should have a parentheses, and our code does have the parentheses. So for the last input is the literal Spotifylum with the big S. So it should return, yes, Spotifylum is the best plant ever. So yeah, it returned that as well. So for the part 3, we'll be using if-else instruction so that we can solve in real life problems. So in this case, we have been tasked to write a tax calculator wherein the country, if the citizen's income was not higher than 85,528, then the tax should be equal to 18% of the income minus $556.02, where 2 cents is equals to $0.02. So this tax is called the tax relief because it is relieving the tax for the people who does not have an income greater or equal to 85,528. So it is a tax relief. So as you can see here, the tax relief is abbreviated or coined as the variable TR. So the TR is equal to the 18% of the income minus $556.02. So if the income is less than that, so we'll have the tax is equal to the tax relief itself. But if the tax relief is less than 0, that is the quirk here, because the statement here has the happy country. If the calculated tax is less than 0, it only means that there is no tax at all. So if the tax relief is less than or equal to 0, the tax is still 0. And if the income is greater than 85,528, we'll read it. If the income is higher than that, so the tax would be equal to $14,389.02 plus 30% of the surplus. Surplus means difference of the $85,528. So income minus $85,528, then you get the 32% of that and add the $14,839.02, then you'll get the actual tax of the taxpayer. So the taxpayer, if the income is greater than 85,528, we'll go here to the else statement, wherein the income is surplus over 85,528, and then we get the 32% of that and add 14,839.02. But the thing is, the tax should be rounded off to the 2 full thalers as indicated here. So that means that we should round the calculated tax into 0 decimal places. That is, we'll have to insert the tax is equals to round the value of the tax into 0 decimal places or to the units place. So now we'll have to figure out the actual input. So let's copy first the code. Into the sandbox, and then if we have an input of 10,000, the tax should be 1244. 10,000, then we have 1244, and you notice the quirk again of the sandbox, but it should be in real Python, it should be not displaying the parentheses. The sample input of 100,000 I believe, yeah, 100,000 is 19,470 as indicated here, 19,470, and 1,000 should expect 0. So the 1,000 should expect 0, and we expected 0, and negative 100 should also expect 0 because it is less than 85,528, negative 100. So the code works well. The tax calculator is done. Part 4, we'll be using if, elif, and else statements. Basically, these are all if, then, and else statements, just like how they work in real life logic. So in this scenario, we are tasked to write a program to determine if a year is a leap year or not a leap year according to the Gregorian calendar implemented on 1582 by none other than Pope Gregory VIII. So there are 4 rules in here. So the first one being, if the year number is indivisible by 4, it's a common year. So we write the code. If the year, I abbreviated the variable year into YR, as you can see here. If the year is not divisible by 4, then we'll be printing common year. But if it is divisible by 4, that is otherwise, if the year is divisible by 4 and if the year is not divisible by 100, it's a leap year. So we have here, if the year is not divisible by 100, then it's a leap year. Or else, otherwise, if the year number is indivisible by 400, it's a common year. So else, if year is divisible by 400, it is a common year. And lastly, when all things fail, then it's a leap year. So we have here printing leap year. So we just copy the code and let's test it if it works. So our first entry should be 2000, and we're expecting it to be a leap year. So 2000 shall be a leap year. The second one would be 2015, which is a common year. 2015, common year. And we have 1999, common year. We have 1999, common year. We have also 1996, which is a leap year. 1996, leap year. And then lastly, we have 1580, which would output not within the Gregorian calendar, because the Gregorian calendar was implemented on 1582. So if we input 1580, it is not within the Gregorian calendar. Moving on to the part 5, we have the while loops. Basically, the while loops function as it would execute the set of code until the condition is fulfilled. In this case, we have a junior magician that picked a secret number, let's say 777, and then he wants that secret number to be guessed. If you did not guess the secret number, it would print, haha, you're stuck in my loop, and you'll be asked again to guess the number. And then if you guess the number correctly, the secret number correctly, then it will output, well done Muggle, you are free now. So we have here now this code which assigns the secret number, and then we print the instructions quite vaguely in such an aesthetically beautiful manner. And then we have the variable here, guess, is equal to the integer of the input of the number, that is what the player has inputted. So we now start the while loop, where if the guess variable, where the guess of the player is not the secret number, then it would print, haha, you're stuck in my loop, and then it will ask again to guess the secret number again. And then if this continues, it would only loop. But if you guess the secret number correctly, we will move on to the else statement, wherein you will be printed, well done Muggle, you are free now. So let's copy the code and execute it. So as we execute it, the secret number is 777. Let's try not guessing it right. Let's say 123. So I've been asked again. 345, I've been asked again. 678, I've been asked again. 345, I've been asked again. And then let's see. As you can see, there are multiple outputs here of, haha, you're stuck in my loop. But if we enter the 777 secret number correctly, it would output, well done Muggle, you are free now. So that's all for this experiment. As for the conclusion, when using the input function, specify the type of data intended to be inputted, for like the integer, float, or literal. This is to avoid confusion when trying to compare a variable to another one. For example, the integer input 2 is not equal to input 2 because an integer is compared to a literal. So an if-else instruction is used to program if-then-else statements. So under the if condition is the then statements, which would in turn execute if the if is fulfilled. The else condition is written in parallel to the if condition. So this if-else instruction just works like how should it work in real-life logic. So a while loop basically executes a set of code until its condition is fulfilled. It is useful for situations involving multiple instances of a function with trials or attempt by a user. Recommendations: always bear in mind that the equal sign is assigning value to a variable, while double equal sign is comparing if values are the same. Also, write the indentions consistently. If the indentation is a tab, all indentions must be performed with the tab. If the indentation is using 4 spaces, then all indentions must be made using 4 spaces. That's all. Thank you.